Look at these soft light rings. You may have seen them in school hallways, retro cafes, or old warehouses. But few people know that to create such a smooth, flicker-free, even light, there is an extremely meticulous and precise production process behind it. Today, I will go back through each step with you to see how this familiar round fluorescent lamp is made. And more specifically, I will also analyze, does fluorescent lamp technology still have a chance to survive in the era of LED dominance? Right after completion, each fluorescent lamp must undergo a rigorous test. Each bulb will be turned on, checked for even light, correct color, and especially for airtightness inside. Bulbs with yellow light, excessive glare, or slight flickering are immediately eliminated. If it were me, I would suggest integrating a light spectrum sensor system right at the test bench. That way, it only takes a few seconds to know which bulbs have color, spectrum, or intensity deviations, saving labor and minimizing the rate of defective bulbs entering the market. You may not know, but each of these fluorescent bulbs contains a tiny amount of argon gas and mercury inside. This mixture, when exposed to high voltage, emits ultraviolet UV rays, stimulating the fluorescent powder inside the tube to glow. However, because mercury is toxic, many countries have banned the production of this type of lamp or tightened safety standards. The future solution that I really like is to replace mercury with special nanobubbles that can generate UV when stimulated by voltage. This technology is being tested very promisingly in Japan and Korea. Do you find the light of fluorescent lamps always feels soft and gentle? The secret lies in the layer of fluorescent powder coated inside the glass tube. If this layer is too thin, the lamp will be dark and pale. If it is too thick, the light will be yellow, even darkening the lamp tube. A very valuable idea that I want to share is using multi-spectrum fluorescent powder, a powder that mixes many different color ranges to make the light more natural, similar to daylight. With this type of retro round lamp, applying multi-spectrum technology will help the light to be both beautiful and maintain the nostalgic style for restaurant and cafe decor. Each fluorescent lamp needs two small fluorescent electrodes at both ends where the current enters and emits UV rays. This sealing step is extremely important because if there is even a leak, the lamp will lose brightness, quickly break down, and become dangerous. If upgraded, I recommend adding a thermal camera combined with AI to analyze real-time images. Any small leak will be detected and handled immediately, reducing the error rate and optimizing productivity. This is the step I like the most. Under a temperature of more than 800 degrees Celsius, the glass tube is softened and then bent into a circle. The workers must be very skillful, accurately measuring the temperature and hand force so that the lamp ring is evenly round, not distorted, not cracked. Modern solution, using a rotating arm robot, integrating temperature and pressure sensors to ensure each lamp ring has the absolute standard diameter. Some factories in Germany and Korea are applying this, and the results are extremely stable. Although LEDs are dominating the market with their long lifespan and low power consumption, fluorescent tubes still have their place thanks to their soft light, low cost, and classic design. My question to you, should we continue to improve this old technology with robots, AI, and new materials, or accept it as a thing of the past? If it were me, I would keep this retro product line for vintage decor spaces, while integrating AI to check the light and multispectral powder to make the light meet modern standards while still maintaining the old look. And you, what would you choose? Keep the classic lamps with improved technology or switch to modern LEDs? Leave a comment, I would love to hear your opinion. If everyone likes, I will continue to make a video simulating the modern LED production process for a detailed comparison.